Have you ever felt that constant tug of war?
Yeah.
You know, you really want the power, the convenience of AI, right, to help cut through all that daily information overload. But then there's that little voice, that nagging concern about, well, your personal data, where's it going? Is it safe? You want to make sense of your notes, maybe your photos, your chat logs, but just the thought of them being shipped off somewhere
Yeah.
to some distant server just gives you pause. It's this weird information overload paradox. You need the AI, but you really demand control. Okay, let's unpack this. Today we're taking a deep dive into a really fascinating new model. It feels like it's setting the stage for a whole new era of personal AI. It's called EmbeddingGemma. And the material we've gathered paints this compelling picture of how this compact but actually incredibly powerful AI tool is fundamentally reshaping those trade-offs we usually have to make. Between privacy, performance, and keeping intelligence right there on our own devices. It's really about bringing serious AI power directly into your personal space.
Yeah, and what's truly exciting here, I think, is that our mission today isn't just to define embedding Gemma. It's really to understand why this model is such a game changer. For anyone who actually prioritizes keeping their data local, right, or needs that real-time AI performance without the lag, and wants accurate results without constantly sending everything back and forth to the cloud. It's about empowering you with intelligent tools that, truly respect your digital sovereignty.
So let's get straight to it then. What exactly is EmbeddingGemma? Okay, imagine an AI, not just powerful, but purpose-built to live right on your device. It's an open embedding model, and it's engineered on the cutting-edge Gemma 3 architecture, specifically tuned for this on-device AI thing. And here's the kicker. It's surprisingly small. We're talking only about 308 million parameters, but it punches way above its weight, delivering serious AI capabilities without needing some cloud supercomputer. Now, for those of you already tracking the AI space, there's this significant shift towards on-device AI. Traditionally, for powerful AI to process your really personal data, those photos, notes, chat logs, right there on your phone or laptop, it often gets sort of quietly shipped off to distant cloud GPUs.
Yeah.
Even when they promise privacy, right? EmbeddingGemma fundamentally flips that script. It does all the heavy lifting right there, keeping your data where it belongs.
Exactly. And, beyond the obvious privacy gains, keeping your data local, what else makes this shift so crucial? Well, think about latency. That annoying lag you sometimes get.
Yeah.
That's virtually eliminated. And operational costs, they go way down. The underlying magic for a lot of AI applications, especially retrieval, it really boils down to, well, smart indexing and fast vector math. And now that math, critically, can happen right next to your data. But this raises an important question. How do we actually make text meaning-rich enough for a computer to understand locally, for that vector math to actually work well?
Right, that brings us to the fundamental idea, the concept of text embeddings. And like we often say, it's not fancy magic. It really is geometry. Text embeddings, they basically map words, sentences, even whole documents into this continuous vector space. And the beauty of this geometry is that similar meaning lands close by, unrelated ideas drift apart. Sort of imagine a complex map where every idea has a precise coordinate, right? And similar ideas are just neighbors grouped together. So the basic flow is actually quite elegant. You embed a query you have, compare that query's unique vector to the vectors of all your documents. Pick out the closest neighbors, those are your most relevant passages, and then you hand those passages over to a language model, a generator, to actually craft an answer. Get that initial retrieval right, and honestly, the rest just feels kind of effortless.
Yeah, and if we connect this to the bigger picture, this is where embedding Gemma truly shines, especially with Retrieval Augmented Generation, or RAG. There's a really critical point to grasp here. Retrieval quality is the fuse. If retrieval misses, generation hallucinates.
Right, that makes sense.
Think about it. If that initial search for information is flawed, the AI's answer is probably going to be flawed too, maybe even completely made up. This model, Embedding Gemma, it consistently pulls the right chunks from your corpus, your collection of documents, and that leads to fewer wrong turns, fewer wasted tokens, and ultimately cleaner answers. And that, in turn, directly impacts user trust and how precise the answers are. When you get accurate, grounded information, you trust the system more. Plain and simple.
Okay.
And what's really impressive is that you can build a simple arg flow with just a few hundred lines of code. It typically starts with normalizing your text, maybe applying task-specific prompts if you need to, then generating those crucial embeddings. You search your vector store, maybe compress or chunk the results to fit, the context budget. Merge those results with your original question and then generate a response. You could do this with a lightweight model right on your device or, if needed, call a larger API. The genius here is this really clean separation between indexing the information and then serving the answer. What that means for you, the user, is incredibly efficient, highly accurate AI answers, because the system always has the best possible information before it even tries to generate anything, which drastically cuts down on those frustrating AI hallucinations.
Okay, so we've talked about the what and the why. Now let's maybe peek under the hood a bit. What makes EmbeddingGemma tick, especially its Gemma 3 architecture? What's one of the first things that jumps out, looking at its core components?
Well, the Gemma 3N tokenizer family is actually a pretty big deal. For developers, it simplifies deployments hugely because it allows for shared tokenizers across both generation and retrieval tasks.
Ah,
That means fewer moving parts, a smaller footprint, which is crucial for mobile, and importantly, it boasts multilingual coverage, over 100 languages.
100. Wow.
Yeah.
Yeah.
Why is that so important? Because in the real world, people search in their own words, their own language.
Sifting through all this material, one concept truly leaped out at me. It was a real aha moment. It kind of redefines how we think about flexible AI. It's called Matryoshka representation learning.
Ah, yes.
For those who might not be familiar, what exactly is Matryoshka and why is it such a game changer for this on-device stuff?
Right. This concept is incredibly clever and practical. Matryoshka representation learning, think of those Russian nesting dolls, right?
Ah.
It concentrates the most useful information at the front of the embedding vector. This means you can actually truncate the vector, cut it down to different dimensions, say 768, 512, 256, or even down to 128, and you still retain a lot of the ranking power, a lot of the meaning.
Interesting.
And this immediately unlocks neat trade-offs. Just imagine this for a second. On a budget phone, okay,
Right.
you could trim the embedding vector down to maybe 256 dimensions and literally double your throughput. Double, meaning it processes information twice as fast. Then, on a powerful desktop, you keep the full 768 dimensions to push for maximum accuracy. And the best part, there's no model swap, no retraining, just a different slice of the same embedding.
That's clever.
This flexibility is huge for deploying AI across all sorts of different devices without needing completely separate models for each one. It's really about getting the right amount of signal for the right amount of compute power you have available.
That flexibility, that's really impressive. But is there a point where, truncating the vector too much starts to significantly compromise that ranking power? Like, are there certain tasks where you absolutely need the full 7068 dimensions, or can Matryoshka really handle most scenarios pretty gracefully?
That's a very fair question. And yeah, while Matryoshka is incredibly effective at preserving the signal, there's always a point of diminishing returns, right?
Yeah.
For really complex, nuanced search queries across maybe extremely large, very diverse sets of documents, you'd likely see the benefit of the full dimensions there. However, for the vast majority of on-device personal search and ARSHA applications we're talking about, the trade-off for the performance gains you get is surprisingly minimal, which makes those smaller slices perfectly viable, really effective in practice.
Okay, this sounds incredibly efficient then. So let's talk about how this actually translates to performance on everyday hardware. The engineers behind this, they really nailed it. It proves that good engineering favors constraints. And EmbeddingGemma lives up to this. When it's quantized, sort of compressed, the model runs with this remarkably small RAM footprint. We're talking under 200 millibit.
Tiny.
Yeah. And latency. We're looking at tens of milliseconds on edge accelerators and modern CPUs or MPUs. That's fast enough for live search, type-ahead retrieval, and voice assistants that do not pause between words. That's real-time responsiveness you can actually feel.
Right.
So it sounds like there are these three core knobs we can turn for performance, sequence length, how much text you feed it,
Yep.
embedding dimension, where Matryoshka gives you that amazing flexibility,
Mm-hmm.
and precision, basically how much memory each number costs. How easy is it for someone to actually play with these? And which one really offers the biggest bang for your buck, especially with Matryoshka in the picture?
You're right. Those are the key levers. And Matryoshka, specifically dealing with the embedding dimension, that is a clear winner for flexibility. You can dynamically adjust it without changing the model itself, optimizing for different devices kind of on the fly. But running locally isn't just about speed, though. It is fundamentally about trust.
Yeah, that's a recurring theme.
Think about it. your sensitive notes. They stay on your device. Your search, it still works perfectly fine on an airplane, completely offline. Compliance reviews become significantly easier because data isn't leaving your control. The entire platform, instead of being this like maze of network calls and cloud servers, becomes a tidy collection of files, indices, and a few small binaries. This simplicity, it pays dividends in both reliability and the user experience. And the real game changer here, I think, is the fundamental shift this brings to how we actually experience AI.
This brings us to a really crucial question. When should you actually choose Embedding Gemma? Like, when does it truly outshine other options out there?
That's an excellent point. It really comes down to where your priorities lie, doesn't it? If you need like the absolute best-in-class accuracy on some massive enterprise-scale corpus, then yeah, okay, larger server-side or big open models might still be your go-to. But if you're prioritizing privacy, local control, and frankly, a bill that practically rounds down to zero,
Yeah.
then Embedding Gemma is absolutely your champion. It's tailor-made for on-device REG, personal search, and those offline applications.
And the practical applications are so compelling. We've seen some fantastic practical patterns at work starting to emerge. One example is personal knowledge search. Just imagine indexing all your notes, your PDFs, emails, calendar summaries right on your own device. The indexer runs maybe when your device is idle, uses smaller embeddings to save storage, and gives you quick one-sentence answers. No more hoping your personal thoughts don't somehow end up training some distant cloud model.
All right.
Then there's the field agent assistant. Think about sales reps or technicians, right? They often work in areas with terrible network conditions. Imagine trying to troubleshoot some complex machine and your knowledge base is stuck in the cloud because you've got no signal.
Yeah, nightmare scenario.
Exactly. With Embedding Gemma, those product specs, troubleshooting guides, price sheets, everything can be packaged right into the app, maybe updated weekly, completely offline. No more, sorry, can't help you, the Wi-Fi's up. And for something really private, a privacy-first messenger. You could search your own chat history, your attachments, entirely offline, maybe with content filters to manage retention. No data ever leaves your device. Finally, a classroom companion. Teachers could create these on-device binders for lesson plans, slides, rubrics, and even share these indices peer-to-peer over local networks. No cloud accounts, no student data ever touching a server. That's really powerful.
And building on that, security is treated as a core feature here, not an afterthought. Marketing local indices as private by default, adding device encryption, clear cache controls, even a simple delete all button. These aren't just technical details. They are crucial user experience elements that build trust. As the source material says, people care about safety. Give them confidence without paperwork. This directly addresses a major user concern with AI today.
Okay, so for those of you listening who might be interested in actually building with this, there's a pretty clear step-by-step path laid out. It involves, preparing your data, installing a toolkit like Python with sentence transformers and fast guys, then encoding your passages, indexing your vectors, searching at query time, and finally generating your answer. You don't need to be like a total coding wizard to get started, but it lays out a very clear logical progression.
Right. And when it comes to tuning, there are some great insights too. We know that instruction prompts sharpen embeddings for the task, so using consistent standard templates for your queries and documents really helps. Also, leveraging titles and fields in your data, that provides crisp signal that can dominate semantic noise. So use your metadata.
Good tip.
And of course, Matryoshka for device tiering is huge. It lets you ship one app, support many devices, just by dynamically adjusting those embedding dimensions. And don't forget quantization. It offers significant memory and battery benefits, often without noticing a difference in the actual retrieval quality.
It really seems like, a lot of teams maybe spend weeks and weeks on generator prompts, focusing so much on the language model itself, while kind of neglecting the retriever, the search part.
That happens a lot.
But the message here seems clear. Shift your attention to retrieval quality and the whole system gets better. And Embedding Gemma makes that shift really practical. It's small, it's accurate, it's flexible. It truly empowers that improved retrieval.
Absolutely. And a huge advantage is the robust ecosystem it plugs right into. This isn't some niche, isolated tool you have to build everything around from scratch. You can leverage existing frameworks like sentence transformers for easy integration. Or run it super efficiently with llama.cpp on your local machine, or even MLX on Apple Silicon.
Wow, lots of options.
Yeah. Imagine it running in your browser via transformers.js or in desktop apps using LM Studio. It pairs cleanly with popular vector stores like Weaviate and Fei, and it truly shines when you integrate it into full pipelines with tools like Llama Index and LangChain. The takeaway here is crucial, I think. This breadth lowers your risk. You're not betting on some niche tool that only works on one specific platform. You're adopting a flexible component that slots into almost any modern AI stack.
Okay, so to kind of sum up this deep dive then, embedding Gemma truly feels like this tiny workhorse enabling fast, private, and dependable AI right on your device. It offers concrete solutions for real-world problems by respecting your user data and your device constraints. And it does it with surprising power and that flexibility we talked about.
Yeah, ultimately, the core message here seems to be that software grows when we respect constraints.
Hmm.
While the cloud certainly has its place, for massive scale, a lot of work belongs right next to the user. And embedding Gemma is just a prime example of this philosophy in action. So what does this all mean for you, the listener, in the long run?
Well, imagine the possibilities, right? If more of your personal digital interactions, things like searching your own notes, maybe summarizing your local documents or organizing your personal files, were handled entirely on device, it offers not just convenience, but genuine data sovereignty, real control. What new applications could you envision? Things that currently feel maybe out of reach because of privacy concerns, or even just unreliable connectivity? Something for you to mull over until our next deep dive.